Hello and welcome to episode 12 in this video series on natural language processing with Python. In this video, we're going to go over how we can create our own function that we can use hand in hand with the frequency distribution function we took a look at in the previous video. So what are we going to change? What we're going to change is we're going to remove punctuation from our frequency distribution. We know that there's going to be a lot of periods because what we're reading in is sentences. Commas are going to be common and other punctuation marks. We can consider this noise or non-value added words, so to speak, that are interpreted in our word tokenize. So how can we do this? We look for them by using the in function, in. So let's go ahead and take a look at a function I created, and we'll run it and we'll see its results. So going from top to bottom, the first thing I do is I import NLTK, or I go from NLTK.probability import frequency distribution, which we saw in the last video. That's the main driving force that generates this distribution. Word tokenize we import, Wikipedia, and then a new one is operator, and we'll see why in a moment. I named the function get frequency distribution to be straightforward so we understand, and for this I'm going to use and pass in the title of the Wikipedia article we want to look up. I like to use that because we can pull from all sorts of samples. We can choose a lot of area, and it's an interesting data source. Alright, so once we get the article passed in, we tokenize the article. The article comes in as a massive string, and we get each individual word. Now, eventually we're going to need a list. And we need to initialize the list before we assign values to it. In some cases in Python, you don't need to explicitly reserve the space for an object, but in this case we need to. So I use the built-in list function. Going down, we have punctuation. So this is the list of characters I'm going to be looking for and excluding from our frequency distribution. It's pretty comprehensive and it's a good start. I ran through some real-world samples of Wikipedia articles, and these are the most common punctuation symbols I came across, so that's where that's from. So if you wanted to modify it yourself or remove part of these symbols, then you could go ahead and do that. This is the list we're using as criteria to remove from the frequency distribution. Okay, great. Now we go into a for loop. So we want to iterate through each word in our article. So that's what we do here, from 0 to the length of that total article. Alright, so why here do I use this lower method? Well, and this came across in the last video, is if you don't look for differences in capitalization, then Python will not know the difference. So THE and capital, lowercase THE and capital THE, the and the, although are the same word, if we don't look for the capitalization difference, we won't spot it. So I'm going to just make sure that every word that's read in becomes lowercase. And this way we don't have to have checks for each word to be upper and lower. We just know right off the bat all the words are lowercase. So here is where we're checking within the punctuation list explicitly stated above. So if it's within the list of punctuation, we execute the first statement, the if, and I use this, I don't know if you call it a function, but I use pass. So what pass does is allows us to execute nothing. It doesn't do anything. Well, why would we not want to do anything? Well, we don't want to add a punctuation mark to the list we're going to ultimately use for our frequency distribution. And if it's not a part of this list, then we append that current word to this no punctuation summary. Now this is the list that we initialized up top before the loop. So we're iterating through a list of words. If there's a period, we don't do anything. We don't append it to the word count or the list of words, we'll say. But if it's not a punctuation character, then we will append that word to this no punctuation list. So that's through the whole length of the article. We're looking at all lowercase letters, and when we get to fdist, which is the frequency distribution, we have no punctuation, and all of the strings are lowercase. And we simply use the frequency distribution, which we imported from NLTK probability, to generate that distribution. Now when I wanted to cite the source of where I got this line of code, and I'll go over the quick high level explanation of it. There's a little more details if you'd like to Google that yourself or look that up. So when we get frequency sorted, when we get F distribution, we're getting a data type of a dictionary. And a quick explanation of a dictionary, if you're not familiar, is it's a way to categorize information. And the way that you store the information is you have a key and you have a value. So it's key and then a colon and then the value. Now, what makes it different from a list is an indexed sequence of items, objects. So when we want to refer to a specific item within a list, we refer to the index. For a dictionary, we refer to the key. Now, dictionaries aren't sorted by order. It's essentially random. Well, there's a workaround in order to sort a dictionary. And what we do is ultimately we're going to execute the sorted function, which, as its name states, sorts information. We use f distribution dot items. Now, what this returns is a tuple. So it's an object that cannot be modified, but this tuple has the word and its frequency. So first, that's what we're ultimately going to be viewing. So this is the frequency distribution content, right? So the word and the frequency. And what we do in this sorted function is we specify a key, and we use operator and then item getter, and we pass it 1. So that was confusing to me at first, but what we're doing is within the items that we have here, we want to sort it by the number that's associated with the frequency for each word. So we're explicitly stating that we have this information presented in this certain way. We have the word and we have the frequency. And what item getter does is says, well, we want to sort by the number that is assigned to it by the frequency distribution and put them in order. So it's a workaround in order to iterate through a dictionary, which inherently has no index. So that's the purpose of that. Lastly, I wanted to have this sorted frequency distribution going from high to low. So descending. Now, sorted returns a list. So it's not a dictionary, and we can use the reverse method. Make sure we're going from high to low, because this sorted by default puts it from low to high. Now, reverse is a method that reverses the list. And the key thing to understand here is we are sorting in place. So what does sorting in place mean? If we were to assign sorted F distribution, if we were to assign this a variable, it would return null, nothing. And that was confusing to me before I understood what sort in place means. So we can't assign anything to a sort an in place modification. You simply just reference the object and it just sorts it. You don't need to assign it to anything. Because if you did, it'd always return nothing. Which is somewhat confusing, but just accept that you don't assign this, you just use the method and it modifies that without returning any other object. Speaking of returning, after we get the sorted list, we make sure it's going from most frequent to least frequent, and we return that. So let's go ahead and run. Run this. Okay. Now when we run it from this script, we automatically import everything, so we don't need to do any of that. So here's the function. Now my name's Robert, so we'll go ahead and look up that. So this will search automatically the Wikipedia article and do the things that we discussed. So did it work? Well, we have this frequency distribution going from most frequent to least frequent. And if I scan through here real quick, I don't see any punctuation marks, which is great. And notice that all the letters are lowercase. Now there's some specialized text here because names will have different languages and other things, but it's pretty interesting. So this function is an improvement over just the raw output of the frequency distribution because we removed punctuation. Let's take a look at one more example of, let's look up, I'm going to look around here for something. Let's look up wallet. Now by implementing this function, we're eliminating a lot of noise from our data set. Noise being information that we don't care about. For your application, you can tweak this. Perhaps you want to remove stop words, or you want to exclude certain things. But this is a good start. And you can use the building blocks of this code to modify it however you like. So thank you for watching this video, and I hope you learned a little bit more about how we can refine this frequency distribution, this built-in set of code from Natural Language Processing Toolkit, and customize it for your application. So thank you for watching, and have a great day.